Hello and welcome to the next episode of Python for Chemical Engineering Calculations. In this short video, I'm going to talk about plotting. We learned how to use NumPy, and now we will plot the data using a combination of NumPy and Matplotlib, a library which will allow you to do that. So we'll start from importing NumPy as usually. In addition to that, however, we'll import matplotlib.pyplot as plt to make it short. And then we introduce an x, which will be just an array from 0 to 10. So it will be len space from 0 to 10, 11 points. And then we calculate y as an x squared, right? So if I run my script now, I can see my variable explorer. This is my parabola, the y of my parabola, but let's show it graphically. So in order to do that, the simplest way would be is to do just plt.plot x, the values on the x-axis, and y, the values on the y-axis. If I run this, well, it says figures now render in the plots pane by default. So instead of looking in the variable explorer, go into plots, and here I can see my plot, which looks nicely like a parabola should look. Well, this is more or less sufficient to start with, but I want to introduce a little more advanced way for plotting so that we can change and control various attributes of this plot. So instead of doing just that, I will introduce a figure. I will say figure is the object figure of the PLT, right? And then I also, to the figure object, I can add axes. I can actually add more than a couple of axes, but I'll start with just one set of axes. So I'll do add subplot, and then after that, I plot using axes.plot and do the same x and y. It's also useful to do plt show if you will be running your script not in the Spider environment, but elsewhere, that line would be necessary. All right. This thing, as you can see, it did exactly the same thing as the first run of the script. It plotted me my parabola. Let's add some more things. So first of all, I can control the style of this line, the color, the markers, the line width, and so on with a bunch of different options Matplotlib provides. I'm not going to cover all of them, but I'm going to cover some. All right, so first of all, I don't like these default colors, so let me make it a different color. If I use B, that stands for blue, it will be a more intense blue color, which I personally like a little more. I can change the line style with the attribute line style, and I can make it dashed line. Other things I can add markers, and I can define the style for these markers, which I'm going to use. So markers would be these circles. Also, I can make the line a little thicker. All right. So that changed the style of my plot. One other thing which is necessary when we plot data, especially if it's not just math, we're talking about the actual chemical engineering data, you certainly need to label your axis. So let's do that. And this is done by axis set x label, and then you write here the string for your label. So let's call it just x axis, and do the same thing with the y and run it again, and you can see that there are labels on my axis now. Another thing, I don't like when my plot starts somewhere at the random point. If I wanted to start from 0 and actually add with 10, I can actually specify the limits for my axis. So I can do x set x lim and give the limits 0 to 10, and x set y lim and give it a 0 to 100. All right, well, it's not that good because we have these markers here at the endpoints, but it still clearly shows the ranges which I specified. All right, what else I can do? I can plot more than one curve. Let me introduce y1, which is, let it be numpy exponent of x, and in addition to plotting the first one, I'll add this one. Plot x, y1. Then let me use a different color. I can use red, and let me use a different line style. For example, I can use a solid line or dotted line. I'm going to use the dash dotted line here, comma, continue on the next line, and then marker, let me use crosses for these markers with 4. Let me make it really thick line. Okay, really thick line so that my markers are barely seen. I can actually work. Another option for markers is just to leave it blank, and then in this case there will be no markers on this line, right? Well, of course we can tell an exponent from a parabola, but overall it's good to label your curves, especially if you're plotting data. These are data for 2 different experiments and you want to label them. So therefore we can introduce labels. So label for this one will be exponent, and label for the first one would be parabola. And in order to show these labels, if I run, nothing is going to happen. To show this, I need to add the legend. So I'm doing axis dot legend. Also for the legend, I can specify the location, and typically what I do, I would specify the location as best, and then Python decides where to put this legend, and I put my legend right here, probably where I would put it as well. Last but not least, yeah, it's nice to see these plot, but how do we get this plot? If we want to use it in our project report or research paper, you need to save it. And Python, of course, provides this option. So before showing the plot, you should do plt save figure, and then specify the name for the file. Plot.png, it will figure out based on the extension of the file you give and save it in the right format. Okay, so presumably it did. One thing I want to mention here, you can also control the DPI, the resolution of your image, so making it DPI 300. Typically the default value is 72 points per inch. But if you want to save it for some professional publication, like a journal article, you'd rather save it in vector format. And if you want to do it in vector format, you should not use PNG, but use a PDF for that. So you, instead of this, you should do plt dot save fig, and then plot dot pdf. That would provide you the vector graphics. I want to show these 2 plots together and tell the difference between the raster graphic and vector-based graphic. So this is the plot saved as PNG, and it looks nice, and this is the PDF plot, which is sort of looks the same. However, if we start zooming in this one, quite soon, despite the high resolution 300 DPI, we will start seeing these dots, right? If we do the same thing with the PDF version, well, no matter how far we zoom in, well, the picture remains clear and not blurry. And that's the difference, because in the case of raster graphic, the picture is saved as a bunch of points. In case of vector graphic, it's saved as a mathematical formula determining the distances to different objects in your figure. And for articles, you probably would like to use the letter.